In the slideshow, there will be 4 different types of databases that will be discussed. These 4 will be the relational database, object-oriented databases, NoSQL databases, and data warehousing. Here is an example of a relational database. Before relational databases were very inefficient and hard to use with trying to access data. What was used was a tab delimited file, and this was where databases were originally flat, so that the information would be stored in one long text file called a tab delimited file. An example on the right of the screen. As you can see, it would be very difficult and time consuming to search for information about an employee or whatever object that has data being stored. In 1970, a researcher at IBM called E.F. Codd wrote a paper about a relational database, and he created the concept of relational databases. Since then, relational databases have been used a lot more in businesses, and they are a lot more efficient and make it a lot easier to search for data about objects that are stored. Here there's an example of a table of how data would now be stored compared to the example in the previous slide. Flat file versus relational databases. A flat file is a database consisting of a single table, which was the first example that we showed. It contains files, records, and characters, and is very simple and easy. A disadvantage is that there would be data redundancy and inconsistency, because data would have to be mentioned repeatedly in the databases. And relational databases then contain entities and attributes, and then you can see the relationships between each entity, which would be displayed in a table that was in the previous slide. And the advantages are now that there's reduced data redundancy, which is repeating of data. There's consistency amongst all the data, so there are no data anomalies when objects are edited or created or deleted. Data is shared, and there's it's centralized security. And disadvantage is to create a relational database takes a lot of time and skill. Relational databases use tables to store information. This new technique of storing data also allows you to sort through data based on any field, generate reports that contain specific fields from each or some records, and to recognize the relations amongst the data. You would search through the databases by using queries such as SQL queries, and call a field with certain fields and display them in a report or in a table. Where does relational come into play? The relational comes into play because there are mathematical relations. Each table contains one or more columns that the other tables can refer to and key on to gather certain information about that table. Applications such as Microsoft SQL, Microsoft Access allow users to create queries and instantly receive call data and have it displayed in tables. Queries will be given constraints, which then allow the user to be selective in the data that he or she wants to call from the database. These queries can only be done because of the relationships that were created amongst the data tables. Object-oriented databases. These are also called Object Database Management Systems, or ODBMS. Database management systems that support the modeling and creation of data as objects. This includes some kind of support for classes of objects and the inheritance of class properties and methods by subclasses and their objects. It uses object persistence. With traditional databases, when data is manipulated by an application, it is transient or non-permanent. Data that is persisted is stored on a permanent storage device. When to use object-oriented databases? They should be used where there's complex data or object-data relationships. So this includes many-to-many relationships. And they should not be used where few join tables exist and a large amount of simple transactional data exist. They work well with CAS applications, multimedia applications, object projects, and the data is stored with two basic methods. The first one is virtual memory mapping, and the second is each object has a unique ID and is defined as a subclass of a base class, using inheritance to determine attributes. These are the ODBMS standards. NoSQL databases. They contain a lot of different databases that were created to respond in the rise in volume of data stored about users, objects, and products. Relational databases were not designed to cope with the scale and agility challenges that face modern applications, nor were they built to take advantage of the cheap storage and processing power. Document databases, graph stores, key value stores, wide column stores. These are a few types of NoSQL databases. Benefits are that they are more scalable and provide superior performance. Their data model addresses several issues that the relational database is not designed to address, such as large volumes of data, quick iteration and frequent code pushes, and object-oriented programming. Characteristics of NoSQL. Auto-sharding. Sharding is a type of database partitioning that separates very large databases into smaller, faster, manageable parts called data shards. NoSQL databases usually support auto-sharding, meaning that they natively and automatically spread data across an arbitrary number of servers without requiring the application to even be aware of the composition of the server pool. Replication. It supports automatic replication and dynamic schemas. They were built to allow the insertion of data without a predefined schema. Data warehousing. The first definition is it's a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. A relational database is designed for query and analysis purposes rather than transaction processing. Subject-oriented definition, integrated definitions, time-variant, and non-volatile definitions are explained. A relational database, a data warehouse environment includes an extraction, transportation, transformation, and loading (ETL) solution, an online analytical processing engine, client analysis tools, and other applications that manage the process of gathering data and delivering it. Breaking down the definition into reality. Subject-oriented, so it can be used to analyze and query a targeted area, and it only fashion data can be viewed if that's what you ask for in the query. Breaking down the definition into reality, it's integrated, so from different sources in order to enable an analysis and queries. And here's an example. Time variant, this is a good example of a time variant. Non-volatile, once stored in the data warehouse, it will never change. Management can therefore access various information from various sources to help them make smart business decisions with data warehousing. A well-managed data warehouses means smart decisions, which means smile on management. Comparisons of databases. A relational database versus NoSQL. NoSQL is better for large volumes of data, whereas relational databases are more for smaller amounts of data and require and can only process smaller things. Here's another very good comparison of relational databases versus NoSQL databases. Relational databases versus data warehousing. A data warehouse contains integrated relational databases that contain various data items from other data stores. A relational database is used for other transactions such as CRUD queries, and data warehouse is for analysis purposes. Object-oriented database versus relational databases. Some advantages are easier navigation and better concurrency control. Disadvantages are lower efficiency when data and relationships are simple, and there's late binding. Late binding may slow down the access speed. The end. I hope this slideshow helped explain quite a few concepts.
Thank you.
Thank you.